let's look at scientific notation. It's kind of hard to write out what you would do in words. So I'm going to work through the examples, and then if you want to go out and put something in these notes, whatever works for you will be great. So example 1 says, convert the number 465,100,000 into scientific notation. So scientific notation, here's how it works. You always have a number and then a decimal. So only one number comes before the decimal. And then you do times 10 to an exponent, and that exponent will be the number of decimals that are left. So in this particular problem, our decimal is going to end up after the 4. And we'll count the decimal places after the 4. So to start, we'll write 4.651. I'm going to go ahead and write out all the numbers besides 0 that are there. 6, 5, and 1 after the decimal. Times 10 to the, and now here's where we need to count. 1, 2, 3, 4, 5, 6, 7, 8. So our decimal or our exponent will be 8. For example 2, we've got a negative number, doesn't make much difference. Our decimal will be after the 6. This is negative 6,400,000. So we'll have negative, don't forget your negative, 6.4, and then times 10, and we'll count after where we're placing our decimal. 1, 2, 3, 4, 5, 6. So negative 6.4 times 10 to the 6. After I finish these notes, I'm going to have to play with my kitty. She just brought me her wand with the feathers on the end. Literally carried it to me. Okay, so example 3 is a little bit different. This time we have a decimal number already. It's a number less than 0, or, well, not less than, between 0 and 1. We'll put it that way. So again, we still want our decimal after the first integer, after the first number, the non-zero number. So that would be after the 6. But this time, since we have a very small number, then we end up, the exponent will be negative. And we'll count our decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 6.5 times 10 to the negative 9. Example 4 works the same way. Because we have a decimal number, we're going to have a negative exponent. And the decimal would be after the 2. So we'll have 2.1 times 10 to the negative 1, 2, 3, 4, 5. The last 4 examples is showing us how to go the other direction. So convert from scientific notation into what we call standard notation. 2.36 times 10 to the 5th. So what we'll do is we'll take our 2.36 and we need to move our decimal 5 places, since it's a positive exponent, to the right. 1, 2, 3, 4, 5. So that'll give us 3 more zeros. So we'll have 2, 3, 6, 0, 0, 0. Don't forget your commas. Commas go every 3 places starting from the right. So you do need a comma here so that we can easily see what number this is. So this is 236 thousandths. Example 6, we have 9.1 times 10 to the 11. So this time we need 11 decimal places to the right again because it's a positive exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the way I do this is I actually start with the 9. And then after the 9, after that decimal, I just start counting. So 1, because we had a 1 there, and then with the zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That just makes it easier for me. And then I go back and put in the commas. So it looks like we have 910 billion. For example 7, this time we have a negative exponent. We've got negative 1.79 times 10 to the negative 8th. So since it's negative, then we need to create a smaller number by moving our decimal to the left. 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Again, I do this by just counting it out. Negative 0 point and then start counting. 1, 2, 3, 4, 5, 6, 7, 8. The 1 will go in that 8 spot. And then 7, 9. And then the last one, 6.646. Take our decimal. It's a negative exponent, so 6 places, to the left. 1, 2, 3, 4, 5, 6. Or again, 0 point, and then start counting. 1, 2, 3, 4, 5, and then the 6 goes in the 6th spot. And then continue with the rest of the numbers. 6, 4, 6. So that's how you can do scientific notation. Let's see. What about if we have a calculator? Calculators give us something different. The calculator isn't equipped to write times 10 to an exponent easily. So what it does is instead of the times 10, it'll put a little e. And then after the e will be the exponent. And it might just say have a number, like in example 9 here, 10. That would be positive 10. It might say plus, like in example 10 plus 8. That would be positive 8. If it's negative, it will definitely say negative 7. Okay? So if there's not a plus or minus out front, assume it's positive. So the calculator output for this problem is 1.2356 E10. In scientific notation, that would be 1.2356 times 10 to the 10th power. It wants us to write it in standard form. So I'm going to write the 1 and then start counting for 10 spaces, plugging in the numbers I have and then zeros after that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then in Excel, you might see a plus here. So it says 2.54 E plus 7. That means 2.54 times 10 to the positive 8. Write it in standard form. We have 2, and then I'm going to count to 8. 1, 2, 3, 4, 5, 6, 7, 8. And go back and put in the commas. And then the last one is negative. We have 9.237 e negative 7. So that would be 9.237 times 10 to the negative 7. And so start counting. 1, 2, 3, 4, 5, 6, 7. The 9 goes in the 7th spot. And then 2, 3, 7. And notice we do not put commas with decimals, big decimals like this. So you've got quite a few problems here to practice with. There's 29 problems, and you can get started on that and email me if you have any problems.